So give applause to Josh Long. Okay. Yes.
What build tool do we want to use? Obviously, these days, the default is Gradle. Who's using Gradle? Gradle. Okay. One person is using Gradle. Who's using Maven? Oh, what is this? Oh, wow. Okay, thank you. Another.
So you don't have to speak so.
Oh, thank you.
So much. Save it instead.
Thank you. Maybe we just pose it. There we go. How's that? We got two microphones. Everybody can hear me in the back. Okay. Thank you. Thank you. It takes a village. I feel amazing. Thank you. So Gradle is the default tool these days. There's one person using Gradle. Who's using Maven? Maven. Who's using Maven? Okay. So a lot of you, and so the rest of you, I guess, are just hoping your code will compile. Hope. Just come on. Come on. Like, is that how it goes? Okay, that's fine. So either way, this is the default. You can still use Maven. Nobody will stop you. It's fine. Gradle is still there. Of course, it's fine. I have a lot of experience with Maven. And so this year, for my New Year's resolutions, I said, I'm going to learn Gradle and I'm going to lose some weight. And, well, anyway, I'm learning Gradle. That's going well. Gradle is good, okay? So that's happening. So anyway, I'm going to build a new application here, friends. And then we have some choices that we have to make. Like what name do we want to give our application? What should be the artifact ID? And I am going to name this service. And the reason I'm going to call my service is because I'm really good with names. Really good. Amazing with names. I get this from my father. My father was also really good with names. We had, when I was a child, we had a small white dog as a pet. And that little white dog, my father named White Dog. Now this dog, we had him for like 10 years. And I don't know what happened to him, you know, I don't know. Maybe he got a job. So, my friends, we have some more choices to make here, okay? We have a choice of what kind of packaging we want to use for our application. Obviously, my friends, I'm a big believer in choosing .jar. This is a part of my overarching guiding principle of make jar, not war. And again, you can choose whatever works for you. Whatever works for you, but I choose jar. And then, my friends, we have the choice of what version of Java we would like to use. Friends, there are 4 radio boxes here, but only 2 valid choices. You see, in order to use Spring Framework 6, you must use Java 17 or later. So these other 2 checkboxes, these are just for the memes. Just for the lulz. Just to find out who makes terrible life decisions. These are never to be selected, ever. They are completely wrong in every situation. Java 8 is technically inferior to Java 17 in every way. It's slower, less secure, less robust, less performant, less syntax rich, less container ready. It's also morally inferior. You won't like the look of shame in your children's eyes when they see you are using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use Java 17 or later. And by the way, friends, I say Java 17 today, but Java 21 is coming in a few months, in September. Java 21 is also among the most important releases of Java ever. Just like Spring Boot 3 is one of the most important releases from Spring ever. Java 21 brings Project Loom. Project Loom is very consequential. And so I think, really, you shouldn't even be targeting Java 17. Today, you should be writing your code against Java 21 and being prepared for that. When that comes GA, that's the release you should be on. No question. Skip 11, skip 17, go straight to 21. So I like Java 17 today, and I think you can all agree, judging purely by the version number only, we can all agree Java 17 is more than twice as good as Java 8. Okay? Now, my friends, we have some questions. We have some dependencies. What dependencies? We want the web support. We want the Spring Boot actuator. We want dev tools. We want the GraalVM native image support. We want the test container support. We want Postgres. We want Spring Data JDBC. Okay? So web, actuator, DevTools, GraalVM native image, test containers, Postgres, and data JDBC, okay? So just some very simple dependencies. We'll hit generate, and that'll create a zip file that I can open up in my IDE. So here's that zip file. We're going to open this up. I'm going to use IntelliJ. You can use whatever you want. It doesn't matter. It's fine, okay? So here we go. Open this up. And friends, I mentioned that I'm using Postgres. Postgres is a SQL database. You need to run it somewhere, right? But I want this application to be as easy to edit and maintain as possible. I want to live that git, clone, run lifestyle. And so in order to support that, there's a nice feature in Spring Boot 3.1 to support easy use of test containers. So here's my main production code right here. Service application, public static void main, spring application.run service application. This is in the production code folder right here, right? You can see source, main, Java, common example service. But in the test package, I have this right here. Oh dear. In the test package, I have this right here. This is my test main code, okay? And so this is a main method just like the first one, but it's delegating to the production code in the production folder, but it has extra configuration. That's this class right here. And this is configuration that is only available during development. This is very useful because now I can run the application, and when I run the application, I'll use the test containers Java API to start a new instance of Postgres. So I have this right here. This is Postgres container, and it's going to use this Docker image to start up a Postgres Docker image container, okay? Now, of course, I don't have to use the latest. You can swap this out with any version that you want, right? It's fine, but let's just say latest, okay? And Spring Boot will automatically connect to this container for you when the application starts up. You don't need to have a separate property file called application-dev.properties or something like this, okay? You can just tell Spring, this is a service connection. And there is similar support for, your other SQL databases, Kafka, RabbitMQ, Neo4j, Redis, Elasticsearch, all these very common integrations that Spring supports, where there is support for service connections for those as well. It makes developing and working in development very, very quickly. And now, friends, I'm going to start the application, but when I start the application, I'm going to use DevTools to live reload my changes. The thing is, my friends, that Java is very slow and Spring very fast. And so if you keep the JVM running all the time, and then just throw away the Spring application context and recreate it brand new, that's very, very quick, okay? But restarting the JVM process, that can be slow. So we avoid that. We just keep the JVM warm and we keep the Spring context and just throw it away on each new recompile. This is usually true. This is almost always true, that Spring is very quick and Java is very slow. But you know what would make Spring slow? If you started a Docker image every single time, right? That's this test container right here. It's going to start a Docker image every single time we restart Spring. So what I want to do is I want to tell Spring, don't restart it for my DevTools recompiles. Keep it running. In order to do that, I'm going to go back to my build, and I'm going to use test implementation for the scope here, okay? So Command-Shift-I, and then we'll go here, and that'll give us this annotation called restart scope, okay? That will tell Spring to keep this bean running the entire time. Don't recompile and restart that one thing, okay? So let's go ahead and run this code. It'll take a little while, because remember, it's going to start up Docker. It's going to start up the whole SQL database, all that stuff. So you can see Docker client factory, Docker server version 1.6.0, creating container for the image, Postgres latest, starting the instance. And it uses the service connection magic to sort of connect to the SQL database there. Very good. There's our connection pool. We're already up and running. We have our application, but you can see that took a long time. The first time, it took 3.52 seconds. Very, very slow, because we had to start a brand new Postgres Docker image. Very slow, okay? So now, we can go back to our production code and build an application. Now, we're going to build an application that talks to our database, okay? So we're going to create an entity here for our data types. And I love Spring, I love Java records, right? Records are really powerful. So I'm going to create an entity here, and by the way, I'm talking about the Java project, not the island. I love the island, you know. Okay, so customer repository. We're going to create a repository like this. Well, come on, Josh. Repository extends list CRUD repository, managing entities of type customer whose primary key is of type integer. We're going to create an HTTP controller like this. We're going to inject the customer repository. Okay, add that as a constructor argument. And we're going to say get mapping customers. And we'll say collection of customers. Return this dot repository dot find all. Now, I'm going to also make this a controller, right? It's a Spring Bean. And I want this application to talk to my Postgres database, but my Postgres database has nothing in it. So I will create a schema.sql file, and I'll say create table if not exists customer, ID serial primary key, name varchar 255 not null, okay? And I will also create some data, okay? Just some sample data so that we have something with which to work. So I'll say delete from customer, hello customer, and then we're going to insert some data into the table, all right? So name, values, my name is Josh. Who else is on the Spring team? It's just a few names. Jürgen, Stefan, right? And we're good. We've got Madura, we've got Olga, we've got Violetta, we've got Yushin, we've got Dr. Sire, we've got, who else? Let me think about that. That is 10 to 3, that's 7, is it? Yeah, okay, so who else can we add? I don't know, Spencer. There we go. So, okay, there we go. There's 3 to 11, that's that should be 8, right? Yeah, math is 2 to 10, yeah, 8. Okay, good. So now we have all this, and I want to tell Spring Boot to automatically initialize the database every single time, okay? Now, I'm going to go ahead and restart the application, but I'm not going to restart it by going over here. I will not do this. Instead, I'm going to recompile the code. I'll go here. Command-Shift F9 on my machine, okay? Command-Shift F9. Now, what that's going to do is it's going to recompile the code. You can see it's doing that down there. And then the application's recompiled, and there. 0.3 seconds, 0.4 seconds, okay? So now you go here, localhost, customers, great, it worked. Of course it worked. It's a demo. It's always gonna work. Now, we're gonna go back to our code here, and we're gonna add a new controller method at getMapping. Customers, name, collection, customer, by name, path variable, string name, return this dot repository, find by name, okay? Like that. Look, you can see the problem here, friends. I don't have this method here. It doesn't exist. So I'm going to use Alt-Enter. I'm going to let the IDE do the work. Take that, ChatGPT. And now we go here, and there we go. Super fast, okay? We have our endpoint now. We have our custom finder method. We have an HTTP endpoint. We have data access. We're living that git clone run life. We're using Java 17. We're using test containers. Life is good. Are we ready to go to production? Not even close. All we have done is build an HTTP API. Any idiot can do that. Even PHP programmers can build REST APIs. This is not important. This is not impressive. We need to think about how to build production-worthy software. And to that end, my friends, there are a number of concerns that we need to think about. The first thing is, how do we make this application more defensible? And one thing you might do in that name is to have validation. You might say that the character, the name, has to start with a capital letter, maybe, okay? This is a simple example, but let's just imagine. The name must start with a capital letter, okay? Very simple. Now, what happens if that capital letter is not true? Well, it's going to throw an exception. And what I want to have happen is that when it throws that exception, we have some component, error handling, controller advice, that catches the exception here, and then does something with it to represent it in a consistent way. And we will use the problem details standard. This is a very easy to understand standard that we support in Spring Boot 3.0 and later, for representing errors in an HTTP API. It's a very easy standard. It's like 16 pages. You can read it on the toilet. You can read it on the toilet. Very, very, very quick. So we're going to create a representation here. PD, problem detail for status. dot bad request dot value, okay? And then we'll say PD dot this and get the message and return PD. Okay, great. So now let's try this out. We'll go here, make a request, curl minus V, localhost, host 8080 / customers, capital J, okay? Now, minus V, okay, that's gonna show me the output. So there's the data. You can see it works just fine. That's the capital letter. Now we go to here, lowercase letter. Oh, thank you. Thank you, Kasi. Thank you so much. Okay, so there we go. There's, oh, no, I need that too.
There's some echo sometimes.
Oh, well,
Yeah.
okay.
I'm not sure which one is much better.
I don't know. I think both of them are making a difference. I don't know.
Ada echo nggak kadang-kadang? Enggak. Aman ya? Oh yaudah, okay. That's good.
Okay, thank you. This elephant is for Postgres. Okay, not for PHP. Or Hadoop. Just Postgres. Okay, so we have this nice problem details representation of the error, okay? Very small thing, very nice, simple, good. Moving on. We have now this error handling logic. What else might I do here? Well, maybe I can inject the current request associated with the error. So I get the headers, and I get the iterator, and then I visit the iterator, and I can print out the results, and so on. So I go here, make another request, go here, and then, whoops, what's it doing? Oh, there, yeah. You can see it printed out the headers, okay? Small thing, small, but I don't care about that. What I care about is this. This is our old friend, the HTTP servlet request. But our old friend has moved here to Jakarta. And our old friend has a new home. Now, to understand why it has a new home, we need to cast our minds back. We need to take a little trip in our memories to a long time ago, far, far, far ago, well before the COVID pandemic, or as I call it, BC. Now, this time was about 5 or 6 years ago. There was a very strange moment in the history of Java EE where Oracle just abandoned the community overnight. And to understand why they did this, you would need to be a lot smarter than I am. I still don't know why they did this, but what they did was they were the lead of a number of different specifications, including the umbrella specification for all of Java EE under the JCP. The JCP is not an open standards body. And so because it's got these lead members control the ability of the community to move any of these standards forward. So if the lead of these different standards just disappears and stops responding to email, then nothing can happen. This is very dangerous because it means one company can stop the whole community from moving forward. And this is exactly what happened. Oracle, overnight, stopped responding to email. They didn't tell anybody why. They didn't tell us when they would come back. They just did it overnight. Suddenly they were there, and the next, nope, nothing. And then this went on for like 6 months or more. And eventually, they came back just long enough to open source Java EE. They agreed to make it truly open by open sourcing it and donating it to the Eclipse Foundation. But Oracle being Oracle, it's never simple, is it? And so what they said was, yes, we're going to open source it, but everything has to be in a new namespace if you make any changes. So if you add a method or delete a method or change a method or change a type or whatever, it has to be in a new package. So everything used to be in this, and it got moved in the Eclipse Foundation. It got donated there, and then the Eclipse Foundation moved it to this new package called Jakarta. Now, the Eclipse Foundation, they were solving a legal and political problem with technology, right? You can't solve that like that, but they did a very good job. The Eclipse Foundation did an amazing job here. What they did was they took Java EE 7, which was under the JCP, the old non-open way. Then they released Jakarta EE 8, which is a new license. It's now OSS, truly open. They created a new TCK. They created new documentation, and they released exactly the same as Java EE 7. No changes at all. No API methods, no nothing, okay? So Then they released Jakarta EE 9, okay? Now 9 had a new package, Jakarta, okay? This is the new package, but it's the same as 8, which is the same as 7, except they moved everything to a new package. So now you've got 3 versions that do nothing differently. There's no new features, no new component model, nothing. It's just that they moved it to a new package. What this means for you is hopefully that you can upgrade your code, and it's just a find and replace. Very easy, okay? You'll have the worst find and replace of your life, and then it'll be over and you're done. You're moved to the new APIs, okay? For us, you can imagine it was terrible. For us on the Spring team, imagine we had Spring Boot 2.0, and then we had to move to Jakarta EE, so all the code in Spring Boot 2.0 broke. Hibernate, Jetty, Tomcat, Undertow, MyBetis, Java OOQ, all these things broke. They didn't work. And so we worked with the community and these different projects to update the types and to upgrade the code to the new Jakarta EE APIs. But this took years. This took years to get right. There is a lot of effort to do this. Remember, the Spring team are the lead contributors to Apache Tomcat. And so we also had to update that ourselves and then pull that integration back into Spring. This took a lot of work. There are people on the Spring team who are bald, who have no hair, completely gone because of this effort. They did that for you. So, we have now new Jakarta EE types. We have, I'll wait for people to come on in. Come on in, my friends. Have a seat, please. What? No, it's very distracting. I'd rather, yeah. Come on in, everybody. Come on in. Have a seat. Glad you're here, but have a seat. All right. Come on in. Have a seat, please. All right. So we have our production code. We have our test code. We've got the defense. We've got Jakarta EE. We've got Java 17. We've got these new. We got error handling here. What else can we do to make this application more worthy of production? Well, another thing that we might do is to introduce observability. And observability is the simple idea that we can understand what the application is doing by looking at its outputs, right? And normally this is supported by a number of different things, right? When we talk about observability, we're talking about logs, tracing, and metrics, okay? So logs, tracing, and metrics. These are the 3 things that define observability. In the old Spring Boot 2.0 world, you have a project called Micrometer, and this supported metrics. And then on top of that, you have Spring Framework. And then on top of this, you have Spring Boot. And then on top of this, you have Spring Cloud. And then on top of that, you have Spring Cloud Sleuth, which supports distributed tracing. Okay? Now, this is the old 2.0 world, but you can imagine the problem here, friends. We have Spring Cloud Sleuth, distributed tracing. If I want to add distributed tracing to a module, let's say I'm working on the Spring Boot team, and I want to add distributed tracing to a module in Spring Boot, I have to pull in Spring Cloud Sleuth. But Spring Cloud Sleuth depends on Spring Cloud, which depends on Spring Boot, so this creates a circular dependency. Spring Boot depends on Spring Cloud Sleuth, Spring Cloud Sleuth depends on Spring Boot, Spring Boot, and so on and so on. It doesn't work. So in Spring Boot 3.0, we got rid of this project altogether, and we pushed distributed tracing down to here, okay? So we have now Micrometer, a new unified abstraction for both distributed tracing and metrics. Micrometer is an amazing project. It's a library that you can use even without Spring, right? So think SLF4j, but for observability. It integrates with a number of different time series databases and distributed tracing systems, including Prometheus, OpenTelemetry, Graphite, Google Stackdriver, StatsD, Wavefront, OpenZipkin, Netflix Atlas, Azure, Dynatrace, Datadog, all this stuff, right? It supports it out of the box. So I want to use this in my application, and we can do that because we have, in our class path, we have this actuator module. This actuator module gives us this micrometer dependency. So let's go ahead and use that in our code here. We're going to add tracing and metrics to our system, okay? So I'm going to create a new metric called by name. passing in null. I'm going to create a context in which to make the request. And in the context, I'm going to need, in order to create that metric, I'm going to need a reservation, an observation registry. I mean, private final observation registry. Okay. Add this to the constructor arguments. There we are. And we're going to pass this in, this.registry. Very good. So now we have this new metric name, right? Metric. And we have this distributed tracing. Okay? So inside of here, inside of this callback, inside of this lambda, if I call another microservice and I use Kafka or the reactive web client or the REST template or RabbitMQ or whatever, anything that supports tracing in Spring, and there's, almost everything does, then it'll automatically either initiate a distributed trace or propagate. It'll start or continue a distributed trace for me automatically. Okay? If I want to, I can also do this using an annotation at observed, but I'm happy with this very explicit style. Okay? So I've got this custom metric called by name, and I have this context in which I'm doing distributed tracing. I want to now look at all those metrics. Those metrics are part of the actuator. So again, I'll go to my application.properties. I'll enable all the endpoints. I'll show the health details. I'll enable the Kubernetes probes, and then we'll restart the application. Localhost actuator. Okay? So I've got these endpoints showing me all the different information about the application, all the different beans, how they're wired together, all the environment variables, system properties, all the properties that Spring Boot can listen to change your behavior of your application. You've got your health endpoint, which shows you your database, your file system, your liveness and Kubernetes readiness probes. You've got loggers, if you want to see all the loggers and how they're related to each other and their log levels. You can post to this to change logging dynamically. You've got a lot of good stuff here, but what I want to look at are the metrics. And here you can see metrics. You can't see that font. See, that's why we should, let me see. Can you see that? Okay, there you go. You can see metrics like how many connections we've got, the databases, how many sessions we have, how many threads we have, all this kind of stuff. How many Tomcat sessions are loaded, all that kind of stuff you can see here. But our metric, the one, HTTP server requests, we can see that. But the metric that we care about, the by name metric, is not there. So let's drive some traffic. While true, do curl localhost 8080 customers Josh. Done. Okay. We'll just let that run for a second. Okay. Go back here, and there's our metric. Okay. And now if I go there, you can see I made 192 requests. The total time for all of them combined was 0.4 seconds. It's 0.01 for the largest single individual request, etc. So now we have metrics and distributed tracing. We have observability. We have error handling. We have problem detail support, Jakarta EE. We're doing git clone run, test containers, easy to start making changes with dev tools. Life is good. I think now we are ready to start thinking about moving and packaging for production. And my friends, to package this application for production, there are two questions that we need to confront. First, how do we containerize the application? Friends, this is an old answer to a common question, which is use build packs. If I want to take my application and turn it into a container, I use build packs. This is an old technology. It's not new anymore, but it's a cloud native computing foundation specification. It gives you a way to take your application and turn it into a Docker image, any kind of application, .jar, .war, Ruby on Rails, Python, Node.js, Go, PHP, I can't say it, it's not a language, but anyway, you could use that too, right? You could use all of those with this CLI easily to create an image. And if you're using Spring Boot, of course, it's even easier, right? So you go here, service. If you're using Maven, you do Maven Spring Boot :build -image. If you're using Gradle, you use Gradle build boot image, okay? Both work just fine. That'll give you a Docker container that you can then Docker tag and Docker push to your container registry of choice. Now, friends, I'm not going to bother with that because I want to focus on the next thing, which is how do I take my application and make it efficient and scalable as possible. And friends, I want to stress before we talk about this that I think Java is already very, very amazing, very efficient, very scalable, And this is represented very well by this blog from 2018 BC, which asks the question, which programming languages use the least electricity? And this is a very old blog, but I think it's a very good blog. There's a great table here that looks at the normalized global results for energy, time, and memory. And you can see there's a lot of great results here. So the table for energy, this is electricity, basically. How much energy does a program that does a similar thing take? So C, the C programming language, uses the least electricity, okay? It is the most efficient for machines, only for machines, not for people, for machines. It's terrible for people. There's also Rust. Rust is doing quite well, 1.03, very good, zero cost abstractions, good job. There's C++, disgusting, disgusting. Moving on, moving on. We have Ada, but who cares? And then we have Java. And Java, let's say that Java is 2.0. 2.0, okay? Simple math, very simple. We will raise it up to 2, just to keep the math simple, okay? Very good, top 5, very efficient language, okay? Moving on a little bit here. We got other languages. We got our old friend Lisp. We've got Pascal. We've got OCaml and Fortran. We've got Swift. Swift is the language that powers all the iOS devices, right? You've got your iPhone and your Android and your iPad and your laptops and your watch and whatever. All that is Swift. And so this is very, very good. It's everywhere. We've got Haskell. We've got C#. We've got Go, Away. We've got Dart. If you've ever used Flutter, you're using Dart, right? That's pretty nice, I guess. This is disgusting. What's happening here? Why is this so much slower? Why allows you to proactively compile your code? The native image compiler is an ahead of time, AOT, ahead of time compiler. And it works really well, but only for code that doesn't have these issues. But there is a way to fix it. Because remember, you can't get rid of this stuff. Java is a very dynamic language. Everything in the Java ecosystem uses some of these features. Your logging libraries, your unit test frameworks, Spring, your data access layers, your web framework, everything is going to use something like this. But there is a way to make it so that GraalVM will work with this dynamic behavior, okay? You need to provide configuration. And you can do this with command line switches or .json files. Now, most of the time, you'll use JSON. I have a few problems with this. First of all, I don't like saying JSON. It just sounds dumb. JSON. JSON. Yeah, no, it doesn't sound good at all. So I also speak French. In my American English accent, JSON, it just sounds dumb. But in French, it's JSON. Which is much cooler, much cooler. You can imagine a French person smoking a cigarette. JSON. Much cooler. I'm a fan. I like this pronunciation. I was in Taipei, and there they have another language, Hokkien. And in Hokkien you can say Jingsong, which means happiness or joy. So either way, if you can be Team Jisong or Team Jingsong, I don't know which one you want to be. Me, I guess I'm Team Jisong. But whatever is good for you, either way, let's move beyond. Let's move ahead and leave JSON. It just sounds dumb. Okay? So Jisong. So that's the first problem, is it just sounds stupid. But we can fix that by not pronouncing it like JSON. We can just say JSON. That's the first thing. The second thing is we have to write a lot of it. A lot of JSON. And I don't want to write a lot of JSON. So there's a new feature in Spring Boot 3, a new AOT engine that will analyze your bean definitions at compile time. It'll give you the chance to contribute at using a Java API. We call them hints, but basically these hints get turned into JSON. And that JSON gets fed into the GraalVM native image compiler. You don't have to do it for most of the applications, but you might have to. And if you want to learn more about this, if you want to learn all about the Spring Boot 3 AOT component model, I have written a book here. It's an e-book. It's a white paper. It's like 49, 50 pages. You can download it for free. It's on the Tanzu website. And just fill out your stuff. It's called Everything That You Never Wanted to Know About Spring Boot 3 AOT. That's this. If you want to download that, you can. Or if you want to watch a little video, I did a video here, 2 hours. And this is the road to Spring Boot 3, ahead of time compilation in GraalVM. And it's a very deep dive, all the way from like beginner to architect, all the way from everything you need to know, library developer, architect, user, etc. All about the GraalVM integrations in Spring, okay? But for our purposes, we don't need to do any of that. We can just use the default behavior. So let's go ahead and do that. We're going to go here, and we're going to start a native image compilation, okay? We'll let that do its work, and that'll kick off, and it'll run. But the problem is it's going to take a long time. And the reason it takes a long time is because GraalVM is doing something called a reachability analysis. And in this analysis, it's looking at the types that you're using, and all the types that they're using, and all the types that they're using, and all the types that they're using, all the way until it has computed a graph of every type in your code base that's being explicitly used. It's kind of like if you went through all your code and looked at all the imports, and looked at all the imports for those imports, and then looked at all the imports for those imports, you would have all the types that you're using. But then you also look at the types in the JDK, and all the types that they're using, and so on. And so it keeps everything in this graph, it keeps that. And it throws everything else away. So the result is that the resulting GraalVM native image code only has the types that your program is using in the JDK, in the class path, in your code itself. If it's not being used in your code, it doesn't keep it. So it works well most of the time, but sometimes it throws away something that you're going to use, something that you'll need. And that's why you have to provide this JSON configuration so that it knows, hey, I'm gonna do reflection. Don't throw this type away. I need that, right? Now, it does take a while. That's the problem. It's a very expensive analysis that it has to do. It takes a long, long time. So long, in fact, that it stops me from, I get bored, basically. I start writing the code, and I'm just sitting there waiting and waiting and waiting and waiting. And finally, I kind of understand this cartoon, right? This is a famous cartoon that looks at the #1 excuse for legitimately not doing a work, which is my code is compiling. And it says, the boss is saying, hey, get back to work. And they say, my code's compiling. Oh, okay, keep going, right? I'd never understood this cartoon before, but now it's 2023, and I thought this cartoon was just for C++ people. But now I understand it as well, and that makes me sad. And the problem with these compilations is that they take forever. They take forever, and so you just lose your sense of focus, you get bored. I just sit there and I hear music in my head. Do you ever go into an elevator and they're playing music in the elevator when you're waiting to go to the next floor and you're surrounded by 30 people and they're all coughing for some reason, right? I hate being in elevators where they have that terrible music. In English we say it's elevator music, and eventually these compilations, they take so long. They take so long that now I start to hear elevator music, and I said to myself, gee, wouldn't it be great if everybody could hear elevator music? So I went to Oracle, and I said, Oracle, please play elevator music during the native image compilation process. And then I said, Oracle, I already hear elevator music in my head when I do these long-running compilations. I'd just like everyone else to hear it too. Thank you in advance, and I appreciate your amazing work. And I do, I really do. The GraalVM team and the Java team at Oracle are doing amazing work. I'm a big fan. So then we got some great responses, including this one from our friends over at Red Hat by a gentleman named Andrew Din. He's a distinguished engineer on the Red Hat Java team, an OpenJDK project reviewer, a Byteman project lead, and a Growl developer. So clearly, this issue was a good use of his time. Now, he said, can we make it this, please can we make it this elevator music? And I think this is a great fit. So this is the soundtrack to the video game, to the movie from the 1990s. And this is a video game for the Nintendo 64 from the 1990s BC. Now, I'm not going to play the music for you, but it's pretty good. It's pretty good. I think that was a great suggestion. We got another response that said, I would add that using beeps in general, not only for native image, really helped me to reduce development time. Yeah, that's a great idea. Imagine, right? When you write your code and it takes forever to compile, at the end you can hear like a ding or a beep or something like that that tells you it's done. My stupid rice cooker can do this. Why can't my compiler this is a great idea. I like this idea a lot. I'm all about this feature. Let's vote this one up. Okay, what else? We got this great response from Fabio Niephaus. Fabio Niephaus is a researcher on the GraalVM team at Oracle Labs. He's a doctor, one of my favorite doctors, along with Doctor Who, Doctor Strange, Dr. Seuss, Dr. Venkat Subramaniam, Dr. David Sire, Dr. DeVolder, and Dr. Pollack, and now Dr. Niephaus. And he gave me this great response. He said, thank you for the feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native image more efficient in terms of time, memory, and CPU consumption. Anyway, he continues, I have prototyped a -- Josh long mode. So let's see what that looks like. This is what that one is, okay? So it's a prototype. You use the native image compiler like this. Pass in -- Josh long mode. And then this is you can't hear it. This is a picture. So you can't hear the music, but imagine there's music, okay? That's the whole point. And then it would show you, it would say, music brought to you by Josh Long, right? Okay? And then of course you're still waiting, you've got good music, but you're still waiting, so maybe you want something nice to look at. So then it shows you this, right? Like that's... Can we agree that would be a cool feature? It would be a cool feature. So anyway, I'm sure that will get merged any day now. I don't know. I'm waiting for that. Moving on. I forgot what we were doing. Oh, the compilation. Right. Let's see. Okay, so it finished after about 1 minute and 10 seconds. Okay. So let's go ahead and run it. Build, native compile. Here's the application. Remember, this application is everything. It's the JVM code, it's all my class path, it's the JRE, it's everything that I need to run this. I don't need a JRE anymore, right? This code is self-contained. This binary has everything to run itself. I can use a very lightweight, minimal distribution of Linux as well. I don't need to support the full JRE to run this application now, right? So I can use a lightweight Linux, I don't need the JDK anymore, I don't need the JRE, and I have just this binary. So it's 83 megabytes. Let's run it, okay? Oh, problem. It looks like I have an existing process running. That's fair, so let's go back here. We're gonna stop the program. Now what? Okay, we've got another problem. It couldn't find the database class because it couldn't connect to the database. Well, that makes sense. Remember, we're using test containers. We didn't have to specify spring.datasource.url or spring data source password or spring data source username. We didn't have to specify any of that. Test containers did the work for us. But now we have a production build. This is not development anymore. So I need to specify those credentials. So let's first start up a database, okay? We need to actually start up a database now. So I'll go here to my desktop, go to the talk, and I've got a little file in here called, it's a Docker Compose file. So I'll do Docker Compose up, okay? And that's going to start up the application using this environment variable, this host and port, etc. That's running. And now I'm going to run the program, but first I will export some environment variables. Spring, data source, URL. Spring, data source, password. And Spring, data source, username. And then I will run this binary. This binary is this one, right? Downloads service, build, native compile, right? So downloads, service, build, native compile, okay? So let's do that. We're going to do run, and there's the application. Now the application started in 0.139 seconds, 0.139 seconds, faster than a light bulb, super fast. Okay, so who cares? If you're building serverless or Knative or something like that, then you can use Spring Cloud Function, right? Spring Cloud Function is an abstraction for serverless, function as a service, Lambda, Knative, these kinds of use cases, right? You can use this to write Spring Beans that get adapted to the function as a service layer. You don't need the full web server for that anymore, right? So these will be even faster, much faster. So you can use GraalVM and Spring Cloud Function together. They're amazing together, okay? There's even, if you go to the Spring Cloud Function project, there are even examples of how to do GraalVM and Spring Cloud Function with your favorite function as a service provider. Okay, but we have an application. It starts up quickly. I don't care about that, though. That's not interesting to me because my application is not serverless. My application is just a web app that I want to run. What I do care about is this. This is the process identifier, 8851. So I'm going to measure the resident set size. The resident set size is the portion of memory occupied by a process that's held in the RAM, in the main memory of the program. So I will measure that here. I'll say PS minus O, RSS, this. That's in kilobytes. So 109,000 kilobytes divided by 1,000 is 109, right? It's 109 megabytes, okay? So if I do some simple math, you can see RSS by PED. There's this. You can see it's using BC to do some scaling. Not the same BC as I've been using, different one. Doing some math, basically. RSS, scale it down, do some division here, and then print it out. So that is this script. There we go. So that's taking, for that process, it's taking 106 megabytes of RAM. Okay? That's good. That's very good. For reference, let's just look at this. Okay, so 57, 16, 16, 40, 72, 80, 35, 124, 40, 39, 41, 29, 82, 67, 29, 37, 161, 59, 197, 42, 77, 46, 166, 21, 16, 40, 208, 3.1, 2. Whatever. All of that is Chrome. It's my stupid browser. What am I doing? I've got like 10 tabs. It's wasting several gigabytes. Look at this. It's disgusting. It's offensive how bad that is. My Java program that can handle production traffic is taking 100 megabytes. One tab takes more than that in Google Chrome, right? This is a good situation. I remember in 2003, I went into a data center. Now, I don't know, some of you are very young. A data center is a big building with cages, and we kept computers in them. And you would go in there, and it's very cold. They have air conditioning, and they keep the computers cold, right? So you go there with your big fluffy jacket, and you plug in your cable, and you log into the computer, and you can look at the RAM and how much resources you got, how much space you've got, are the logs overflowing, all this kind of stuff. 20 years ago, I did this. 20 years ago, I went into this data center, and I remember looking at all these computers. 20 years ago was a long time ago. This was when dinosaurs still roamed the earth. And this is when people believed that application servers were a good idea. They were never a good idea. And so back then, even 20 years ago, we already understood that it was a bad idea to put more than one application inside of an application server, because you would get these noisy neighbor issues. If one application ran out of RAM, it would exhaust the others, and they would all fall over together, right? So in order to make things more resilient, we'd have one application server and one application, right? And it would be like an onion, right? That would make you cry. An application server onion. And we knew this was a bad idea, but there was no better way to do it because you couldn't put more than one application in one application server. And so this took about 2 gigabytes of RAM 20 years ago. Okay? Now, at the time, I was thinking, I want more RAM. And the reason I wanted more RAM was because this was getting very inefficient. It was starting to get slower. I needed more RAM. We couldn't usefully add more RAM though, because we only had 32-bit CPUs and 32-bit compilers. So that if we tried to use more than 2 gigabytes of RAM for the JVM, you would get these very slow garbage collection pauses for a whole second, and the service wouldn't work, right? So we didn't bother. We just stuck with 2 gigabytes of RAM. Now we have 64 gigabytes of RAM. You can probably allocate a lot more RAM if you want, but why do you bother? My program now runs in 5% of the RAM that I used 20 years ago. This is a very good time to be a Spring and Java developer, my friends. Okay, so we have now a service. Let's build a client. I'm going to go back to my second favorite place on the internet. Start.spring.io. And we're going to build an application that's going to act as an API gateway, as a back end for a front end, as a edge service for our application. Okay? We're going to hit generate, and I'm going to open this up in the IDE. Here we are. Where's my water? Downloading everything. All right, so this application will be it's the thing that allows us to handle cross-cutting concerns for our network services so that we don't have to change all of our downstream APIs. We can just handle these common concerns here, okay? And one pattern that we might use is an API gateway. So what I'm going to do is I'm going to use Spring Cloud Gateway to describe a matcher that when a request comes in on localhost 9999/proxy, we're gonna capture that request and then proxy the request and send it to /localhost 8080/customers. The problem is this is the path, but the path of the request that comes in is already .proxy. So I need to use a filter here to change the path, right? So I'll say set path customers, okay? So that's one filter, but there's a lot of other great filters. Maybe I want to retry the request. Maybe I want to add cores headers, right, like this. I can do all these things with filters. You can do all sorts of other things as well. Maybe I want to do JSON to gRPC, right? No problem. Maybe I want to do token OAuth relay, like that, okay? Maybe I want to do circuit breaker, like this, or rate limiter, right, like that. So all these things you can do with these custom filters. If you don't see the filter that you need, then just write your own, no problem. Easy, 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 okay? So let's go ahead and restart this and go to the command line, curl http localhost 9999/proxy -v, and you can see we've got this custom header, we've got the JSON, everything is working. We did not have to change our microservice to add this new header. The API gateway pattern is great for load balancing and compression and routing and security and all this stuff. Very easy to add this to a system using Spring Cloud Gateway. Okay, now what if I want to actually work not with the envelope of the data, not with the body, not with the container of the request, but what if I want to work with the data of the request, the data of the service, okay? Well, here I must build an actual client. So maybe I can do this. Maybe I say class customer HTTP client, and I can imagine using the non-blocking HTTP client like that. And maybe in my client I have a method here to return a non-blocking reactive stream of results. But you can already see some of the problems with this. First of all, I don't have this type. This type is not on the class path. So I will do something terrible, something that you must never ever do, ever. Not even when you are all by yourself at home and no one is looking. I'm going to copy and paste code. So we're going to go over here and we're going to take this result here and we're going to paste that into the code base and it's working, okay? So now that's a little bit better, but still this seems like work. I don't want to do work. So instead I'll use another new feature in Spring Framework 6. Spring Framework 6 has moved this support from Spring Cloud down into the framework and unified the abstraction. So now I can create declarative interface-based methods, right? So here's what I'll do. I'll say, I want this method to correspond to a call to that endpoint called customers by name. And I want this method to correspond to a call called customers. And now I'm going to use a factory method to turn that interface into an actual implementation. So I'll say customer HTTP client. And in order to do that, I need to build up this HTTP service proxy factory. And I'll say web client adapter for client. And I'll inject the reactive non-blocking HTTP client. So builder.base URL HTTP localhost 8080.build. Okay. Got create client. Good. So that's all I'm going to do. I'm going to use that to automatically create an implementation of that interface for me. Okay. Simple. Now let's close that out. Good. So now we can go over here and we can use this when the application starts up. We'll inject that client that we just created and we'll log the results. So http.customers subscribe. We're just going to print out the results like that. Command Shift F9. Voila. Okay. So there's the data, the JSON. We made the call to the other service using our interface, and that's all. And it automatically worked correctly. It made a call to another service. So now what will we do with this customer client, this new client? And by the way, we support RSocket as well, and we are working on supporting GraphQL. So you can create a client for any service using a nice interface, and that's it. You don't have to implement all the networking code. But what can we do with this? Why would we build this client in the first place? What we would do is build a view of the data. We build a representation of the data that's appropriate for our clients, our iPhones, our Androids, our Apple TVs, our Rokus, our Xboxes, our PlayStations, our cars, our laptops, our desktops, our TVs, everything has an SDK. And there's a bit of a conflict here between the way that we build services and the way that clients consume our data. Clients want all the data all at once. They want everything in one payload. But services, they want to be separate. They want to be isolated. Microservices, singly focused. So clients don't want to make 10 different calls and get all the data and then put it together in the client. That's very wasteful of network resources. It's wasteful of battery. It's wasteful of time, the user's time. So they want to have everything all at once. But back-end engineers, we want to keep everything nice and separate. How can we solve this conflict? Well, GraphQL is a great way to do this. So I'm going to go here, and I'm going to create a GraphQL application. I'll create some schema, okay? GraphQL. So in GraphQL, you can represent types in your application like this. You define schema, name, string, okay? And in GraphQL, you have 3 verbs. So queries, you have subscriptions, you have mutations, okay? Mutations are for add, add, delete, delete, update. Subscriptions are for streaming requests, okay? And this is for request response, short-lived, okay? So these are the 3 verbs. Obviously, in order for that to work, we need a way to define what are the queries, what are the mutations, and what are the subscriptions. So we define a type called query. And here we define our fields, our endpoints. I'm going to have an endpoint called customers by name, and another one called customers. So customers by name and customers, okay? Good, so there's our fields, and we need to actually implement these two fields in the GraphQL API. So we're gonna go here, create some GraphQL controllers. We'll say add controller, class customer, GraphQL controller, private final customer HTTP client. Okay, I'm going to inject that, and I'm going to create a method that gets invoked whenever somebody wants to resolve this field on the type called query. So when somebody wants to get all the customers, they'll call this method, and we'll call into our client to get all the customers. Well, what about all the customers by name? Same thing, right? Do that here. Customers by name. Argument, string name, by name. Okay? So there you go. There's my two different methods, passing in that. Now I want to try this out. I need to test it. I need to enable the graphical console. Okay? Command-Shift F9, localhost 9999 graphical. Okay? So now we've got this new declarative client that we can use to make requests of the GraphQL endpoints dynamically. So let's just start. Let's clean up my existing tabs. I've got that running. But remember, I'm still on port 9999. I just used Spring Boot to create this graphical console for me easily. So now I can say query, customers, right? I'm using control space. I get tab completion. I get schema. How nice, right? It's just there out of the box. You don't have to use Swagger and all this nonsense. So now I've got this result set. I've got these customers here. Great. What if I want to get the customers by name? Okay. Ask for that. I shall get it. So now notice that the client, I didn't have to ask. I didn't make two network calls. Okay. So I get that back. Okay, great. So now I've got the profile for this customer. What about this one? I go down here. Profile, ID. Okay, now I've got that profile as well. You see that for each customer, I've got the profile. But the problem is, my friends, remember, I'm printing this out. So look at this. If I go down here, you can see it's calling this resolver, this method for each profile. So if I have 8 customers, it's calling this method 8 times. That's not good. It's not obvious why that's not good, but imagine that there's actual latency, right? Imagine I've got actual latency there. Now I make a request, what happens? I make a call to get 8 customers, and then I have to call the profile service 8 times. That takes 8 seconds. 1, 2, 3, 4, and it takes forever. So the engine is calling things sequentially. This is bad. So imagine now that I want to optimize this by using non-blocking reactive types. Okay? So instead I'll use reactive non-blocking types like this. Okay, there we are. So I'll say return this, mono.just, and I'll delay each one by a second. Okay? So I'm going to redeploy, refresh, and this will just take 1 second, not 8 seconds. So now I'm getting the same results in just 1 second instead of 8 seconds. So it's concurrent. But still, this isn't very good. I'm still making 8 network requests. I'm doing n+1, right? Not good. So I can go a step further. I can use batch mapping. And the contract here is very simple. Given a list of customers, I have to return a map of profiles. So new hash map, customer, profile, for var c, customers, map.put, c, new profile, c.id, return map. Right? Good. Now close this off. And I'll say I'm going to return, system out, returning all profiles. Okay, customer, there you go. So Command-Shift F9, run this again, and now you can see it's returning all the profiles at once. It's giving me every single customer. So it's making 2 network requests. One for all the customers, and another for all the profiles. I've gone from very inefficient sequential-based network calls to concurrent network calls to just 2 network calls. I went from slow and serial to concurrent to, and I had n+1 in the first 2 versions, to just 2 network requests. And the entire time, the client has not changed. The JSON that I'm sending back to the client is exactly the same this entire time. Nothing has changed. GraphQL is great for building service interfaces, for building APIs that can be the front end for lots of different back ends that decouple the representation of your data from the implementation of the data. And GraphQL is a great way to build services. So we have this simple code. Let's clean it up a little bit. I mean, obviously, this is very verbose, right? Remember, I said queries are special cases. So we'll use @query mapping instead of this longer form schema mapping. Same thing here, right? Schema mapping can be replaced with query mapping, okay? And here, I'm just using batch mapping. You know, I don't need to specify the field because it's implied by the name of the method. So this is functionally the same as what I had before. Okay, friends, we've got now our service, we've got our client. Let's go ahead and turn it into a native image. Gradle W, native compile. We'll let that run and do its work. Now, friends, obviously, we've only just begun to scratch the surface here tonight. We've talked about that git clone run life. We've talked about Spring Boot 3.0. We're looking at Java 17. We're using Jakarta EE. We're looking at the new unified observability abstraction. We're looking at the new problem detail support. We're looking at the nice error handling support. We're also looking at how to use GraalVM native images and the new AOT engine. We talked about some of the reasons why the AOT engine is worth understanding. Then we looked at the client, and we looked at different patterns like the API gateway and GraphQL and the new interface-based declarative clients. And we did all this using the current technology. But I want to invite you to look just a little bit ahead, just a month or two, to September of 2023, when Java 21 will come out. Java 21 brings Project Loom. Project Loom, like I said, is an answer to the question, how do we make blocking code more scalable? And the answer is you change the mechanism behind the scenes so that magically it's not blocking anymore. And to understand this use case, to understand what I mean, think about this code. var in equals var input stream, right? Okay, so whatever, I'll just to do, okay? We'll come up with that. And then var next equals -1, okay? So you've written this code in university. All of you have, I'm sure, right? While next equals input stream dot read does not equal -1. While that's true, then do something with the data, right? Do something with next. Well, what happens if this is a network socket? Get input stream from client socket. What if that is a socket? What if the client is a chat and nobody has sent a byte? Nobody has typed anything. So you're sitting there waiting for the next byte, but nothing is coming. Well, that means that this code will be stuck there, right? Got another byte. This won't execute until this method returns. This means that this method is blocking. And normally for a network service, you have a thread pool. Each request gets a new thread, and then in that thread, you have the input stream and the output stream. You read from the input stream, produce a response, send it on the output stream. Basic network server 101 kind of structure. The problem is, if you're doing this code in a thread, then that thread it's impossible to use that thread for anything else in the system. And today, the way that Java is implemented, threads are very expensive. If you create one thread, one Java Lang thread is equal to one operating system thread. So you cannot create thousands and thousands of threads because each thread will take about 2 megabytes of RAM. This is a problem, right? So there's a famous problem in computer science from the 1980s or 90s called the C10K problem. The C10K problem asks, how do I build a service that can handle 10,000 network sockets at the same time? Back then, this was considered almost impossible. Today, for Java, if you write code like this, it's impossible. But the reason it's impossible is because today, threads are expensive, but not network sockets. Network sockets are cheap. I can easily handle 10,000 concurrent network connections. I just can't handle 10,000 threads. So what if there was a way in Java to break that coupling so that the logic for handling the network socket is separate from the thread on which it was started? That's what Project Loom brings. It brings a new virtual thread pool. This virtual thread pool will look at this code. There's an engine in Java now that will look at this and it'll say, oh, hey, you're waiting for the next byte. The next byte has not arrived. I'm going to take this code, put it in RAM, and I'm going to give the thread back to the thread pool. And when there's a byte, I'll put the code back on the thread, like a suspension, like a coroutine almost.